Many objects behave as if their masses are concentrated at a single point. If we toss a wrench in the air, it might twist and turn, but if we were to only plot the center of mass, then the path is a parabolic trajectory. Okay, so assume that we have two objects, a cat and an elephant. We put them on a seesaw. Now, where do we need to put the single point called the center of mass so that the seesaw balances? This point is called the center of mass. To answer that question, we position this in the xy coordinate. The center of mass is labeled x bar. The position of the cat is x1. The position of the elephant from the y-axis is x2. The distance from x1 to x bar is called d1, and d2 is the distance from the center to the location of the elephant. m1 and m2 are the masses of the cat and the elephant. m1 d1 equals m2 d2 if we were to balance the seesaw. But d1 is x bar minus x1, and d2 is x2 minus x bar. This is what we call the directed distance from the y-axis. Multiply them out. We have m1 x bar minus m1 x1 equals m2 x2 minus m2 x bar. And we group the x bar terms on the left, the other terms to the right-hand side, and we factor out x bar. We then isolate x bar because that is what we're after. We're looking for the center of mass x bar. And so x bar is m1 x1 plus m2 x2 over m1 plus m2. m1 plus m2 is the total mass. m1 x1 is called the moment. m2 x2 is called the moment. X bar is also called the fulcrum. The center of mass x bar is on the x-axis, but it is measured from the y-axis. So m1 x1, m2 x2 are the moments, and they were computed using the distance from the y-axis. The sum mi xi is called the moment. In this case, it is called the moment of the system about the y-axis. Remember, the distance xi are from the y-axis. It is denoted by my, to remind us that it is the moment about the y-axis, even though we use the x-coordinate. So mx equals m, the mass, times y. The mass times the directed distance from the x-axis. Y distance from the x-axis. And so we're using the y-coordinate to find the moment about the x-axis. My is mx, which is what we computed earlier, the mass times the directed distance to the y-axis given by the x-coordinate. Mx and my are called the moments. Moments are additive. That means we can add them up. And so the moment about the x-axis is m1y1 plus m2y2 plus all the way up to mn yn. So it's the sum as I go from 1 to n, mi, yi. The moment about the y-axis is m1 x1 plus m2 x2. So the sum of mi xi as i's go from 1 to n. The total mass is m equals m1 plus m2 plus mn. So that is the sum at I go from 1 to n of mi. Now earlier, to find x bar, we take the moment about the y-axis divided by the total mass. And so in the 2-dimension, we would do the same thing. X bar is going to be my divided by m. So that is the moment about the y-axis divided by the total mass, where my is the sum of all of the moments about the y-axis divided by the total mass. And y bar is the moment about the x-axis divided by the total mass. So the sum of all of the moments about the x-axis divided by the total mass. For example, find the center of mass of the system of 4 particles having the masses 4, 2, 5, 1 at these locations. So first, we put them on the coordinate system, xy. We have 4 points with the corresponding masses. So to find x bar, y bar, first we find the total mass. The total mass is 4 plus 2 plus 5 plus 1, which is 12. Next, we find the moment about the y-axis. The moment about the y-axis is computed using the product of the mass times the distance from the y-axis. And so the distance from the y-axis, the x-coordinate, we take the mass times the corresponding x-coordinate, and we keep doing that for how many particles there are. Again, the moment about the y-axis is the product of the mass times the x-coordinate, because it is how far from the y-axis. How far you are from the y-axis is measured by the x-coordinate horizontally. And so the moment about the y-axis is 12. The moment about the x-axis is the sum of the product of the mass and the y-coordinate. And so the mass times the y-coordinate, the mass times the corresponding y-coordinate. And so the moment about the x-axis is 7. So x bar equals my over m. So the moment about the y-axis is 12, and the total mass is 12. So x bar is 1. And y bar is mx over m, which is 7 over 12. So the center of mass is 1, 7 over 12. The system balance if we put the center of mass at 1, 7 over 12. Now, unrelated to the problem that we just did, we have a different system where x bar is 2.4 and there's only 3 particles. If we move the y-coordinate of the particles up and down, then x bar is still 2.4. We can move all of the points, or we can just move a few points, but x bar is still 2.4. In fact, we can line all of the particles up in a straight horizontal line, and x bar is still 2.4. If y bar is 16.08, we can move the x-coordinate of the particle to the left and to the right, and y bar is still 16.08. In fact, if we line them all up on a straight vertical line, x bar is still 16.08. What that means is that we can line the points up on a straight horizontal line or on the straight vertical line to find the moment about the x-axis and the moment about the y-axis as if they were in a one-dimension case.